Hi, are these gemstones? Even up close, it can be hard to tell if they are amber or not. Imagine you could tell it at a distance using your vision only. These ultraviolet lights claim to let you do just that, making it much easier to find amber. And these glasses claim to protect your eyes against the ultraviolet light. Really? Let's find out, including if these are amber or not. Can you guess it? Intense ultraviolet light can hurt your eyes and skin. Wear UV safety glasses and sunscreen to be on the safe side. In Denmark, we have no precious minerals to mine on land, just dirt and clay. No gemstones to find either, except for an organic one, the gold of the North and Vikings, amber. 40 million years old fossilized resin from pine trees. It is just difficult to distinguish from a lot of amber-colored stones. Apparently, ultraviolet light will make it easier. I have two so-called amber flashlights, ravlygter in Danish. They are simply high-intensity ultraviolet lights. A small one with 5 LEDs and a big one with 100 LEDs. Guess which one is the strongest? The one with 100 LEDs does not mention wattage, but they look like inexpensive standard 5mm LEDs, so maybe a total of 6.8 watts. Seems about right compared to this smaller version with 51 LEDs that is listed as 3.5 watts in the Norwegian specs. How about the one with only 5 LEDs? It is listed as 30 watts. Not sure if that is the whole truth, but it does have a noticeably more intense beam. The 100 LED version is more of a floodlight. For being mostly ultraviolet and therefore invisible lights, they are both quite strong though. Let's check their spectrums. Both are listed as being centered around 395 nanometers. UVA light just below visible light's wavelengths, which typically is said to start at 400 nanometers as visible violet. First, the one with 100 LEDs. Yep, that surely is centered around 395 nanometers and stretching into the visible spectrum. The other one is, well, similar. Perhaps half a nanometer longer at the center and less visible output up into the cyan colors. Both have a lot of ultraviolet output, so our eyes can't tell how strong the light really is. That's why we must wear UV safety glasses when using them. I hope this pair will do the job. They claim to follow an ISO standard, but I only trust my own measurements. How much of the wide spectrum from this halogen lamp will they attenuate? Promising start. The glasses look yellow-orange since they absorb most of the blue and violet. Green and red light mixed to yellow, and with an overweight of red, it is an yellow-orange or amber color. Now for the real test. How much from the amber flashlight will go through? Oh, okay, that's a success. I wouldn't trust them for UV lasers, but for UV flashlight, they are fine. Alright, everything is fine so far, but will the invisible UV light really make amber visible at night? With a normal flashlight, I don't spot anything unusual here. With UV light, hey, I do see a difference. It is even clearer with the safety glasses on. Let's go closer. The 8 pieces glowing greenish yellow are real amber. The dark pieces are wannabes. This works better than I was expecting. But what is going on? Why does it work? After a short message, I will try to explain it and show you an even more striking example. Thank you so much to all my patrons. You really make a difference in financially challenging times. If you want to help me make more videos like this one, check out the Patreon link in the description. You will also get full access to my bonus content for just $1 a month. Thank you. Why does amber appear to emit a greenish yellow light under UV light? Because it does emit the light. It is not just a reflection of the UV light. It is a phenomenon called fluorescence. In short and simplified, some of the electrons in the amber can absorb a photon from the high-energy invisible UV light. By absorbing the photon and all of its energy, the electron gets an energy boost, making it jump into a higher energy orbital around the atomic nucleus. But the excited electron does not stay in this higher orbital. It emits some of the absorbed energy by vibrational relaxation down through some suborbitals. It basically heats up the amber a tiny bit before making a final jump to its ground state. This final jump emits a new light photon. The new photon has lower energy than the originally absorbed UV light since some energy was lost to heat. The lower energy photon is what we see as visible light coming from the amber. Invisible light has been transformed to visible light. The amber simply absorb high energy UV, convert a little of the energy to heat and spit out the rest as lower energy visible light. Fluorescence is fascinating and quite useful in this case. The electrons in the rocks can't absorb the UV light. The jump only happens if the UV light has exactly the energy needed for the electron to make the jump. The electrons in the rocks don't have the matching energy levels, so they can't fluoresce under UV light. I have tried to find some scientific papers on exactly what chemicals in the Baltic amber are fluorescent. Oddly enough, we don't seem to know for sure. The most precise guesses I have found are pyrene, excimers of pyrene, or even pyrene tetrasulfonate. In a rare type of amber called blue amber, which fluoresces a greenish blue, the fluorescent part is believed to be perylene. Now I should mention that not everything that fluoresces is amber. Here are two examples of rocks that have fluorescent edges, but they are not amber. There are also minerals that have much stronger fluorescence. Here's an example from Greenland. I believe this contains various flavors of sodalite, including hagmanite. On the normal light, it looks like marble, but on the UV light... Wow! This is just nature showing off. With glasses on, it reminds me of lava. What a beauty! Click like if you agree. Let's conclude it all by testing the two pieces from the intro. Are these amber? Whoops! White paper is very fluorescent. Let me switch to a non-fluorescent background. There we go. Only the one on the left is amber, which I can confirm from picking them up. The one on the right is too dense and rock hard to be amber. It's just a translucent rock. Thanks for watching. Bye for now.